Welcome to Go Lesson 17, Interfaces. Interfaces define behavior contracts. They specify what a type can do, not what it is. In this lesson, you will learn to define interfaces, implement them implicitly, and use type assertions. Interfaces are the key to writing flexible, decoupled code in Go. Let's start with interface basics. An interface is a set of method signatures. Any type that has those methods implements the interface. Go interfaces are implemented implicitly. No implements keyword needed. This shape interface requires area and perimeter methods. Any type with these methods automatically satisfies the shape interface. Rectangle has width and height fields. We add area and perimeter methods. Circle also implements shape by defining the same methods. Notice we never said circle implements shape. Go figures it out. Both rectangle and circle implement shape, so we can use them interchangeably. The output shows both shapes correctly calculating their areas and perimeters. Now let's see the real power of interfaces. Polymorphism. Polymorphism means one function can work with many types. If they all implement the same interface, they are interchangeable. Our shape interface now has area and describe methods. Rectangle implements both methods. Circle also implements the interface. We add a third shape, triangle. Same interface, different calculation. Print shape info takes any shape. It does not care about the concrete type. Total area takes a slice of shapes and sums their areas. We pass rectangle, circle, and triangle to the same function. We can put different types in one slice because they all implement shape. Each shape describes itself and calculates its area correctly. Now let's explore the empty interface and type assertions. The empty interface has no methods, so every type implements it. It can hold any value, similar to object in other languages. We assign strings, integers, floats, and booleans to the same variable. Type assertions extract the concrete type from an interface. The syntax is value.parentheses with the type inside. Use the OK pattern to safely check the type. If the type is wrong, OK is false instead of causing a panic. A type switch checks multiple types in one statement. The syntax uses v.parentheses type to match against cases. We test strings, ints, floats, bools, and slices. The type switch correctly identifies each type. Finally, let's look at the stringer interface from the FMT package. Stringer has one method, string, that returns a string. When you print a value, Go calls its string method if it exists. Any type with a string method implements stringer automatically. Person implements stringer to provide a custom string representation. Temperature formats its value with a degree symbol and unit. Money adds the correct currency symbol based on the currency code. When we print person, Go uses our custom string method. Temperature displays with proper formatting. Money shows the currency symbol before the amount. The stringer interface gives you control over how your types appear. Let's recap interfaces in Go. Interfaces define behavior with method signatures. Types implement them implicitly. The empty interface can hold any type. Use type assertions to extract values. Stringer lets you customize how your types print. Thanks for watching. In the next lesson, we explore embedding for composition over inheritance. Like and subscribe to continue your Go journey.